Hello students, today we will start uh, two types of rectifier circuits, half wave rectifier circuit and full wave rectifier circuits. Okay, so what is a rectifier? Rectifier is a device which converts AC voltage into DC voltage, that is alternating current voltage into direct current voltage. So this is the function of rectifier. Rectifier is a device which converts AC voltage into DC voltage. So to get a DC output voltage, three types of rectifier circuits are used. One is a half wave rectifier circuit, second is a central tapped full wave rectifier circuit, and third is a bridge rectifier circuit, bridge full wave rectifier circuits. So today we will learn about half wave rectifier circuit and central tapped full wave rectifier circuits. So this first figure shows the half wave rectifier circuits. So in this half wave rectifier circuit, only one diode is used. Only one diode is used. In this circuit, there is one step down transformer, diode D, and load resistance RL. Now, see the circuit operation of half wave rectifier circuit. AC input voltage 230 volt AC, it is applied to the primary of the transformer and it is induced into the secondary due to the mutual induction property of the transformer. Due to the mutual induction property of the transformer, the AC voltage in primary is induced into the secondary. As the transformer is a step down type, therefore we get less AC voltage. Less means if the transformer is 0 to 9 volt secondary, then we get 9 volt AC across the secondary winding. Okay, this secondary voltage is then applied to the rectifier circuit or to the diode. In a half wave rectifier circuit, only one diode is used. So let suppose this is our terminal A and this is terminal B. Then during the positive half cycle of this AC input voltage, during the positive half cycle, let the terminal A of the transformer be positive, then terminal B will be negative. And therefore, since positive is applied to anode of this anode of this diode, the diode gets forward bias. The diode is forward bias. That is, when diode is forward bias, it offers very low resistance, or it just acts as a switch, closed switch. Therefore, current flows through diode. Current flows through diode. As the terminal A is positive, then anode is connected to the positive, and cathode of this diode is connected to the negative. That is to the terminal B. Therefore, diode D is forward bias, and current flows through diode through load resistance RL toward the point B. The circuit is completed, and since current flows through load resistance RL, voltage is developed across RL, and thus positive half cycle appears across RL. It is a pulsating DC voltage. Now, during the negative half cycle of this AC input voltage, the terminal A becomes negative and terminal B becomes positive. And since terminal A becomes negative, therefore anode is connected to the negative terminal. Therefore, diode is reverse bias. When diode is reverse bias, then it offers a very high resistance. That is, it just like it acts just like an open switch. It acts as an open switch. Therefore, no current flows through diode. That is, it does not allow to pass the current through it, and it acts as an open switch. No current flows. That is, the current is blocked. During the negative half cycle, current is blocked, and therefore no current flows through the diode. Again, during the positive half cycle, again terminal A will be positive, and at the same time terminal B will be negative. Therefore, diode D becomes forward bias. It acts as a closed switch, and current flows through diode through RL to the point towards the point B, and thus circuit is completed, and DC voltage is developed across the load resistance RL. This type of voltage is called as pulsating DC voltage. Pulsating DC voltage. Okay. Now, what is the average DC output voltage? The average DC output voltage is given by the formula VDC is equal to Vp upon pi. Vp upon pi. VDC, in case of half wave rectifier circuit, the DC output voltage VDC, average DC output voltage VDC is equal to Vp upon pi, where Vp is the peak voltage of the peak voltage, that is Vp means 1.414 into Vrms. Suppose the transformer is 9 volt secondary, then Vp is equal to 9 into 1.414. It is called as peak voltage Vp. So the average DC voltage VDC is equal to Vp upon pi, and Vp upon pi means 0.318 into 0.318 into Vp upon pi, that is 0.318 into how much? Vp. 0.318 into Vp, because 1 upon pi means pi means what is the value of pi? 3.14. 3.14. So 1 upon 3.14 means 0.318. 1 upon 3.14, that is equal to 0.318. Therefore, average DC output voltage VDC is equal to 0.318 into Vp. Then, what is meant by peak inverse voltage? VIP, peak inverse voltage of the diode. So when the diode is reverse bias during the negative half cycle, of AC, the diode terminal AB will be negative, and hence since terminal A becomes negative, diode is reverse bias. So when diode is reverse bias, then all the voltage across the secondary full voltage appears across the diode, and this is the reverse voltage or reverse bias voltage. So Vp is equal to Vp means peak inverse voltage. So what is peak inverse voltage? Peak inverse voltage is the full voltage across the secondary voltage which appears across the diode when it is reverse bias. When the diode is reverse bias, the full secondary voltage appears across the diode, and this voltage is called as peak inverse voltage. So it is the maximum reverse voltage across the diode. The diode should withstand for this voltage without damaging it. That is, to avoid breakdown, the peak inverse voltage VIP is equal to it should be equal to Vp. PIV of the diode should be equal to Vp. So PIV means peak inverse voltage. So PIV is equal to Vp. Then what is the maximum efficiency of this half wave rectifier circuit is 40.6%. The maximum efficiency of half wave rectifier circuit is 40.6%, and the ripple factor eta. What is meant by ripple factor? Ripple factor is the Vrms AC output voltage divided by DC output voltage. Vrms AC divided by VDC. It is called as ripple factor. So ripple factor of half wave rectifier circuit is 1.21. Okay. So this is about half wave rectifier circuit. Then next we will study about full wave rectifier circuit, center tap full wave rectifier circuit. So in a full wave center tap rectifier circuit, a center tap transformer is used. Then two diodes D1 and D2 are used, and load resistance RL. Okay. So when AC input voltage is applied to the primary, it induces into the secondary, and as the transformer is stepped down, we get less AC voltage. Suppose 909 or 12012, such type of transformer is used in rectifier circuits. So during the positive half cycle of this AC input, during the positive half cycle of this AC input, let terminal A becomes negative with respect to center tap, then the terminal B will be negative. Therefore, the diode D1 is forward bias, and at the same time diode D will be reverse bias because terminal B is negative. Therefore, diode D2 becomes reverse bias and diode D1 becomes forward bias. Therefore, current flows through diode D1 through RL towards the center tap and again towards the point A. Thus the circuit is completed and current flows through load resistance RL in only one direction. Then during the negative half cycle of the AC input, the terminal A becomes negative while terminal B becomes positive. Therefore, diode D2 is forward bias and at the same time diode D1 becomes reverse bias. Therefore, the diode since diode D2 becomes forward bias, current flows through diode D2, then through load resistance RL, and through center tap and lower half winding toward the point B. Thus, during the positive half cycle and again during the negative half cycle, current flows through load resistance RL in only one direction. Therefore, since current flows through load resistance RL in only one direction, hence DC voltage is developed across RL. This DC voltage is called as pulsating DC voltage. DC voltage. Okay. Now, what is the average DC output voltage of this circuit? Full wave rectifier. The average DC output voltage VDC is equal to 2 Vp upon pi. 2 into Vp upon pi, that is 0.636 into Vp. Then since both diode conducts, therefore the peak inverse voltage PIV is equal to 2 Vp. PIV is equal to 2 into Vp, where Vp is the peak secondary voltage. Vp. So PIV is equal to 2 Vp, and the maximum efficiency of center tapped full wave rectifier circuit is 81.6% and ripple factor is 0.48. Okay, ripple factor is 0.48. Okay, so we will stop here.